This is the continued portion of RCBD design. Just we have seen the previous videos, the RCBD design with equal replication and its concepts also. And in this video, just we will see the missing plot technique in RCBD design. And sometimes data for certain units are missing, or some observations become unusable due to several factors. For example, when an animal becomes sick or dies, but not due to the treatment defect, and when rodents destroyed a plot in the field experiment, and also in case of CRD, when a flask breaks in the laboratory, just we can calculate the missing plot technique or use missing plot technique in such cases. And an estimate of a missing value does not supply an additional information to the experimenter. It only facilitates the analysis of the remaining data. And when the single value is missing in RCBD design, just we can estimate the value by using this y is the missing data, and the formula looks like the product of R into R with or replication, a number of replications multiplied by what it's the block, the observed values of a block containing missing data, treatment times treatment total with missing observation, and subtract what grand total with missing observations, that means, and divided by the error degree of freedom for RCBD. This is what the formula of error degree of freedom in RCBD design. For the estimated value is submitted in the table with the observed values, and the analysis of the variance performed as usual, with 1 degree of freedom being subtracted from both the total and the error degree of freedom, because the estimated value makes no contribution to the error sum of squares. When all of the missing values are on the same block or in a block and treatments, the simplest solution is to act as if the block or the treatment had not been included in the experiment. Just if the observation, the missing value is only in the same block or in one treatment, just considered as the treatment was not found in the block. That means, for example, in the table given below are the yields kilogram of 4 varieties of yield of 4 varieties of maize in 4 applications planted in RCBD, for which one plot yield was missed. Then we have to estimate, as requested, that estimate the missing value and analyze the data. Here are what the varieties 1, 2, 3, and 4. 4 varieties, or those varieties are considered as our treatments. Just the levels of the varieties or number of varieties are considered to be the treatments, whereas here are all the blocks or replications 1, 2, 3, and 4. So 4 varieties replicated 4 times. Here are also the observations. Now the green yield for these varieties, this one in replication 1, and it gives, or it's what observed this much gram of green maize in this replication, and similarly all this green yields was obtained from each replication, from each treatment. But the second variety, or in the second treatment and in the second replication, one treatment or treatment 2 was not found. That means this treatment was missed in replication 2. Based on this, just we have to arrange and estimate the treatment totals, the grand total, and also the block total. Block total is calculated downward. That means this is the column wise, and in rows. This is in row 1, 2, 3, 4 gives the block total, whereas column 1, 2, 3, 4 gives the treatment totals for each variety. So variety 1 treatment total is this one, and variety 2 treatment total this one. Considering the absence or the absence of this one, just we have to use the symbols BO and TO. This one, the treatment total for treatment 2 with missing value, meaning TO, whereas BO meaning the replication 2 total with missing value. That means whereas GO also the grand total with missing values. When we add or sum up these all values, this will obtain this much grand total, or we can obtain also in other case by summing up all these values, but the value is similar. So the first is estimating the missing value. Just missing value is estimated as R times BO, or block total with missing value, plus treatment times treatment total with missing value, and minus the grand total with missing value, and divided by area degree of freedom for RCBD design. So if we substitute all the values, R is 4, that means replication 1, 2, 3, and 4 for replication, times BO means a block total with observe what missing value, this is BO, and plus 4, that means the treatment, the number of treatments were 4, and times 39 with treatment total 2, this one with missing value, and subtract the grand total with missing value. This is the grand total with missing value. Then the missing value will be finally 13.9. And then the second step is enter the estimated value and carry out the analysis. So the corrected treatment total is 39 plus 13.9. 39. This is what the missing value. This value is expected to be for this plot or for this observation. Then we have to estimate again the value of this, and this. Based on this, first we have to estimate the corrected treatment total, and in order to get this, the treatment 2 total, this one, plus this one will give us this one, and then we have to calculate the block total, because here also the missing value, or the block total is missing value. So in order to adjust this or correct this, just we have to add the estimated value, this one, and it will give us this, and also the grand total also similarly will give us this, and we have to substitute for the next steps. So the third step is carrying out the going to do the analysis of variance or ANOVA after we have put the missing value and the corrected values for each totals of treatment and block, as well as the grand total. The first one is calculating the CF. CF is calculating us squaring the grand total with corrected values divided by n, and so it will be this one. CF will be this one, and treatment sum square is total CSS is calculated as squaring all observations and summing up, and then subtract the correction factor. So the first observation was 18.5 and square this one, plus the second observation was 11.7 and square this one, then 13.9 square and plus, and last observation was 15.7. just you can see the table. The last observation was this one, so we have squared all each observations and then summing up to 15.7. It is the last observation, and then divided by what subtracted correction factor, then total SS could be this one. And the third one is treatment SS or treatment sum square. This is what squaring the treatment totals and dividing by replication and subtract correction factor from this value. And we'll have also this much. That means each squared values are the replication totals in with corrected what treatment total, and divided by 4, which is replication, and subtract correction factor this much, and we will have this much amount of treatment SS, or 31.21. And then the next step is calculating the block SS. So in order to get this, we have to square all the block totals. The block totals, that means block 1, block 2, block 3, block 4, squaring those all values and summing up, and divided by the treatments, the number of treatments, 1, 2, 3, 4, and after we have divided by 4, then the value obtained from this will be subtract correction factor, and we'll have also 9.02. So the fifth step is estimating the error SS sum square. To get this, just we have to subtract the value of treatment SS, block SS from total SS, and similarly the total SS was 79.18, subtracted this value and this value. You can add this and this value at a time and subtract the total from total SS. So we'll have also this much, this value. And then the next step could be what? Estimating the square values, the mean square values. In order to get the mean square values, we have to do that where, for example, treatment mean square is calculated as dividing the treatment sum square values by its degree of freedom, meaning 31.21 divided by 3 will give us some value, and block mean square is equals to block sum square divided by block degree of freedom, that means 9.02, that the values here we obtained here, divided by 3, and we'll have also some value. So the values were here are here this, and then the ethical treatment ethical if calculated as also treatment mean square values obtained from this calculation divided by degree of freedom, and then block calculated block F calculated is calculated as, or also block mean square values divided by degree of freedom. So those values are here 0.61 and 2.19 respectively. So the next step is, if tabulated, use treatment degree of freedom and error degree of freedom as denominator and denominator in for treatment F tab, whereas B block degree of freedom and error degree of freedom for block F tab, and read the values from F distribution at 1 and 5 level of significance. That means at 1% for treatment F tab, just we can get that for both treatment F tab and for both for block F tab at 1%, we can get 7.59 because of the error, and also the treatment number and the block number are similar or equal. We will get similar values from F distribution in the distribution table. Similarly, if at 5% also, because of similar treatment degree of freedom and block degree of freedom, just will have also similar values for block and for treatment F tabulation at F distribution. having 4.07, not 40, it's 4.07. And then the last step is subtracting 1 from error degree of freedom and the total degree of freedom and complete the analysis of variance table. Here are the tables, and then submitting all the values calculated before, and see the effects, or also interpret the results. And lastly, just we have to calculate the CV value and put below this table, or always the ANOVA table. So based on this, we have got those values, all the values, the sum square values here, and also you can again check by yourself also. And here are also the mean square values, and here are also the F calculated values. If you use this value in case of block, the value of F calculated for block 0.61 is less than this one. So this indicates that insignificant. There was no significant difference between blocks. That means using blocks was not efficient in controlling an experimental error in or variations. That means, whereas when you see the treatment, similarly, this value 2.19 was lower than or less than the value of F table at 5%. That means 4.07, and this indicates that there was no significant difference between the treatments treated. And what conclusions from this experiment or from this table and the procedure we have? That means, so there were no significant difference between yields of 4 maize varieties. So because of this, we can conclude, because of the ANOVA table for treatment, because there is what treatment is designated as NS, that means not significant. We can say that there were no significant difference between the yields of 4 maize varieties, because our treatments were for 4 varieties and the data was yield. So due to this, there was no significant difference between the yields of 4 maize varieties, we can say. The other one, the block was not efficient in controlling experimental data, and no need of estimating the extent and the magnitude of error reduction or block efficiency. That means, because from the ANOVA table, the block was insignificant. If the ANOVA shows insignificance, just no need of estimating or going to do the analysis of what the relative efficiency of the block, because this indicates that the presence of inefficiency, or the block was not efficient in controlling experimental in RCBD design. That means the other one is according to Gomez, and Gomez CV for varietal trial, which is acceptable up to 8%, is higher, and there were higher variation in the experiment, but tolerable up to 30% for field experiments. So different scholars suggest that for field trials, the CV value or CV percent value is accepted up to 30% for field experiments, and no need of mean comparison at all for this experiment, because the ANOVA tells us the presence of insignificance or no significant difference between the treatments. So I would like to say thank you very much, dear students. Just you have to read more from your book and watch this video frequently, again and again. Read, watch, hear, please, again and again. I strongly request you to read, to hear, and to watch frequently to understand the concepts and the procedures all over the ANOVA of RCBD. And just if you read, more, if you just watch more, if you listen and hear more from the videos, not only from this video but also from related topics of the others video, just you can teach yourself and you can get more information from any source, so please let's read more and watch frequently. Thank you very much.